In this video, I'll take a look at how to use the 80-328P timer registers to blink a light on the Arduino Nano with 1 second delay between turning the light on and off. First, a quick overview on the steps needed, then I'll look at some of the timer registers, and then I'll look at some code. And for the sake of brevity, a lot of detail will be simplified. The 80-328P timers work by counting clock signals, but the 80-328P is clocked at 16 MHz, and the maximum value for a timer/counter is 65535. There is a built-in prescaler to divide the clock signal for this purpose. I'll configure it to divide by 1024, giving a 15625 Hz signal. This is then counted by a timer register. There is also a comparison register, and when the two are equal, it triggers an interrupt to turn the light on or off. TCCR1A and TCCR1B are timer control registers. The COM bits are for setting compare output mode and will be set for normal operation. WGM stands for wave generation mode, and these bits need to be set for clear timer on compare match mode. CS stands for clock select bits, and these need to be configured to divide the clock signal by 1024. TIMSC1 is the timer 1 interrupt mask register. I'll skip most of these bits, but the output compare A match interrupt enable flag needs to be set. And finally OCR1A, a 16-bit output compare register. And now for some code. The 80-328P has 25 interrupts in total, and when these are triggered, an address in the first 50 bytes of program memory are called. So, one line of code at the beginning of program memory that runs on power on or reset. Hex 16 is the interrupt address for timer 1 compare A, the relevant timer interrupt, and place the rest of the code after any and all possible interrupts. Now I am setting up the registers. I'm using the last byte of RAM to hold the LED status, so I set the stack pointer to 1 less than RAM end. I disable interrupts while setting up the timer interrupts. I set the direction of pin 13 to output. I initialize the timer count register to 0. All the bits in the TCCR1A register are set to 0 by default, but I still need to set the clock select and wave generation mode bits in TCCR1B. I enable the timer compare interrupt. I re-enable global interrupts, and enter an infinite loop. Now the interrupt handler. Interrupt handlers must exit with all the registers, including the status register, the same as when the interrupt is called. So I push R16 onto the stack, I copy the status register onto R16, and push onto the stack again. I load R16 with the byte at RAM end because that holds the LED status. I increment it to alternate bit 0. I copy R16 back to RAM. I skip the light on instruction if bit 0 of R16 is cleared, and I skip the light off instruction if bit 0 of R16 is set. I restore the status register and R16 from the stack, and return from interrupt. I upload it to the Arduino, and here it is working. Thank you for watching.